Hello there, children. Today, we are to work in section 2.6, linear inequalities in two, yes, count them, two variables. This educational experience is brought to you by your visionary variables, Sarah Faust. That will be me. So, let's get started. Now, some definitions here. The graph of a linear inequality in two variables is a half plane, or half a graph. To graph a linear inequality, follow these steps. Step 1. Graph the boundary line of the inequality. Use a dashed line for less than or greater than, and a solid line for less than or equal to, or greater than or equal to. A boundary line is just a line, folks, so you're going to graph the line like you would graph any other line. Now, use dashed lines for less than or greater than. How does that make sense? Well, if you think about it a little bit, remember back in chapter 1 when we graphed linear inequalities in only one variable, these things required us to use an open dot. An open dot means an open or a dashed line. These were a closed dot, which means a closed or a solid line that we're going to use. Alright, so once I get done graphing it, here comes the new part. To decide which side of the boundary line to shade, test a point not on the boundary line to see whether it is a solution of the inequality. Then shade the appropriate half plane or side of the graph. So you're going to graph a line, and obviously your line is going to take your graph paper or graph or whatever you have and cut it into two pieces. You then test a point not on the line to see if that solution works. So let's do an example here. Alright, example number 1. Y is greater than 2x plus 1. Well, what type of line do I have? This is a greater than, so it's a dotted line. So then I'm simply going to graph like the line is y equals 2x plus 1. That means I'm first going to go and use that y-intercept there. And then I'm going to use my slope of 2 going up to the right one or down to the left one. Now I have a dotted or dashed line. Remember, arrows at both ends here. Now, I test a point not on that line. You can test any point over here or any point over here. The easiest one to test usually, folks, is 0, 0. So I check that point. So you check 0, 0 or any other point that you choose to use. So 0 is greater than 2 times 0 plus 1. 0 is greater than 2 times 0 plus 1. That's going to be greater than 0 plus 1. 0 is greater than 1. No, it's not. If you think it is, I will give you $0 if you give me $1. Anybody? No? That's silly. Correct imaginary voice in my head. That is quite silly. No, this is not a true statement. So, I cannot use the point 0, 0 because it gives me something false. So I use and shade that side of my graph. Sound effects optional. Now, what does this mean for us? That means any point in this region over here will satisfy that inequality right there. So if I pick the point -2 for x, 2 for y, I'll get -3 on here and 2 over here. And yes, 2 is greater than -3. So any point over here will work. Now I know what you're thinking. Do I always have to check points? And the answer is not necessarily. If, and only if, folks, the y is isolated on the left side, you can use this neat little trick. You want y is greater than that line? Greater than the line goes above. If it were less than, it would go below. That is only for if the y is isolated by itself on the left. Just like, remember, if the x in chapter 1 was isolated by itself on the left, you could just shade whichever way the arrow pointed. Let's go to another example. Y is less than -x plus 3. Alright, so I am going to have a dotted line here. Why? It's less than, not less than or equal to. Alright, so then I plot my y-intercept of 3. And then my slope of -1 goes down and to the left, or right, excuse me, or up and to the left. draw your dotted line. Remember, arrows at both ends. Now I check the point 0, 0 again. Now I know what some of you are probably thinking. But can I use that trick you just talked about, Mr. Faust? Yes. Yes, you can. But I'm showing what if you forgot that trick. So I check 0, 0. 0 is less than negative 0 plus 3. Is 0 less than 3? Yes, it is. So I'm going to shade below the line because 0, 0 is over on the left side of the line, and it gave me a factual statement. So it is part of my solution set, which, if you think about it, kind of makes some semblance of sense. There's a lot of S's in there, I know. Because guess what? Less than, below. All right, moving on. Y is less than or equal to negative 2x plus 1. Ooh, hold up. Hey, that is now going to be a solid line. Solid indeed. Why is it going to be solid? Well, because it's less than or equal to. So I'm going to graph again my y-intercept of 1 here. And then I go down 2 to the right 1, or up 2 and to the left 1. Solid line, folks, because remember, what? It was less than or equal to. Now, which way do I shade? Again, I could check 0, 0 because it is not on my line. So I go ahead and do that. Now I know what some of you are thinking again. Is that trick available to me? Yes, of course it is. And why? The y is on the left. Very good, imaginary voice. The y is in fact on the left. Now, is 0 less than 1? Why, it most certainly is less than 1. Oh, happy days are here again. So I shade down here, which makes sense. If you recall that trick, y being less than goes below my line. Now, the shading should not be above my line there, but again, I'm using a gigantic marker to do this. All right. Moving on up in the world. Now, this problem. Oh no! It's not in y equals mx plus b form. Gasp! Whatever do I do? You've got two options. Option 1. You just go, I'm going to deal with this and find my x and y intercept. And how do I do that? Remember, when you're looking for the x-intercept, you cover up y. And when you are looking for the y-intercept, you cover up x. So if I cover up the x value here to find the y-intercept, I get negative 2y equals 4. Means y equals negative 2 for my y-intercept. And for my x-intercept, I'm going to cover up the y. I get 2x equals 4, x equals 2. And I can graph my line like that, using my two intercepts. Or, what you can do is go, I don't feel like dealing with that. No, thank you, sir. I am simply going to solve it for y. Why am I going to do that? Because I really, really, really want to use that awesome trick of the shading thing we just talked about. Now I divide everything by negative 2, because sharing is caring. So, when I do that, I get x, and then a minus 2, because remember, I'm dividing every single term in this entire problem by negative 2. But when I do that, I also have to flip the inequality around. So I either graph it using my x and y-intercept, x-intercept being 2, y-intercept being negative 2, or I graph it using this, y-intercept being negative 2, and using my slope of 1, being up 1 over 1. Now, or down 1 to the left 1. Does it matter which way you do it? No. Here are some advantages. This method, the intercept method, allows you to do the problem fairly efficiently and quickly by simply covering up one variable. Disadvantage, you can no longer use the arrow trick because the y is not isolated by itself. Advantages to using this method, You get it in y equals mx plus b, which everyone can graph, and since you're isolating the y on the left, you can actually use that arrow trick. Oh, happy days, you're here again. Negatives about that. You end up dividing by things and having to flip inequalities around, and you can make a mistake if you're not careful. Now, if you're like, I don't want to use that arrow trick, Mr. Faust, then you don't have to. What did I do wrong here? Oh no! What type of line should I have? A dotted line. Whatever will I do off on a test? I graphed this. Well, guess what? Two ways. You can simply erase part of your line, making it dashed or dotted. That's available to you. Or the other way is simply, if you did it in pen, simply put this line should be dotted. That's also acceptable. Now I'm going to again check the point 0, 0, because if I use my intercept method, I can't use that arrow trick available to me. So I get 0 times 2 minus 2 times 0 is greater than 4. That means 0 minus 0 is greater than 4. 0 is greater than 4. No, it's not. So I can't shade above. I must shade below the line, which doesn't follow that trick, remember. Unless you go over here and look at y equals mx plus b. Since the y is isolated, I want y's less than my line. I would shade below. So you have options ahead of you. Remember, the choice is yours and yours alone. You graph however you feel would help you the best. You do you, as the kids say. Now, you're ready to tackle the world and the homework. Go henceforth and do.